Hi, good morning to all. Welcome to my channel Calculation. Today we are going to see about real numbers. In our last class we learned about introduction. In that I explained you about a natural number, whole number and all the other numbers. If you need any clarification, I can give a link in my description box. Please check it. Now let us start our new topic, real numbers. In the real numbers, we are going to learn about Euclid's division algorithm. Real numbers. In this chapter, we are going to learn under two topics: Euclid's division lemma, fundamental theorem of arithmetic. Today, we are going to learn about Euclid's division algorithm. A positive integer a can be divided by another positive integer b in such a way that it leaves q as a quotient and or as a remainder. Before entering into a theoretical part, I can give you an example. For example, if we divide 75 by 2, we will get an answer 37 and the balance one. In this 75 we will say as a dividend and 2 as a divisor, and the answer will be a quotient and the balance will be a remainder. I can give one more example. 38 divided by 3. This 38, after dividing by 3, we will get 12 as an answer and 2 as a balance. This 38 we will say as a dividend, and this 3 is a divisor, and the 12 answer is a quotient and 2 as a remainder. Now let us move into our theoretical part. Any positive integer a, this 75, can be divided by another positive integer b, that is 2, in such a way that it leaves q as a quotient, this 37 as a quotient, and or as a remainder, this 1 as a remainder, is smaller than b. In this case, this remainder we will say as a r, that every time it will be greater than or equal to 0, that is, this every time remainder will be either equal to 0 or greater than 0, but it always lesser than the divisor, this 2. We can implement this equation. This a is equal to bq plus r, where 0 less than or equal to or less than b. How we can implement this equation with this example? 75 is a dividend, this 2 is a divisor, this 37 as a quotient, and 1 as a remainder. Next example, 34 divided by 3. In this, 38 is a dividend, a equal to 3 is a divisor, 12 is a quotient, and 2 is a remainder. Applications where we are using this Euclid's division algorithm. We are using this Euclid's division algorithm to find out the HCF of two numbers. In our earlier classes, we have learned this HCF of two numbers in a normal method, but here they are using this Euclid's division algorithm to find out this HCF of two numbers. So now we will see about HCF. HCF is the highest common factor. Find the HCF of 9678. Okay, now let's find about the HCF of 96. 96, 2, it's divisible by 2, 48, again 2, again 2, 3. So next we are going to find out 78. These are the factorization for 96 and 78. After calculating this, we find out that for 96, these are the multiples. For 78, these are the multiples. So now we can see what is the HCF of 78. That is the in both it need to be in common. 2 is a common, 1 twos are 2, and 3 is a common in 96 and 78. So the HCF of 96 and 78 is 6. I took this example so that it helps you to understand easily. A trader was moving along a road selling eggs. An idler who didn't have much work to do started to get the trader into a woody duel. This grew into a fight. He pulled the basket with eggs and dashed it on the floor. The egg broke. The trader asked the idler to pay for the eggs. When the idler asked how many eggs there were, the trader replied, "So, if counted in pairs, one will remain. If counted in three, two will remain. If counted in four, three will remain. If counted in five, four will remain. If counted in six, five will remain. If counted in seven, it remains zero. So, my basket cannot accommodate more than 150. Let us try to solve this puzzle. A is equal to BQ plus R, where where R is greater than or equal to 0 and greater than less than B. So, as the seller said, maybe he had an egg lesser than or equal to 150. So, we will take as an assumption A is lesser than or equal to 150. With this assumption, let us try to solve this problem. If counted in pairs, one will remain. So what will be? A is equal to, this is A, that is A is equal to in pairs. So 2 into quotient plus 1 will be the remainder. How we can write this? A is equal to 2 into quotient. Anything we can multiply plus 1. The answer will be A. If counted in threes, 2 will remain. That means A is equal to 3 of some quotient plus 2 as a reminder. 3 of quotient plus 2 as a reminder. I hope you can understand this. Okay. If counted in fours, 3 will remain. That means A is equal to 4 of quotient, some quotient we will multiply plus 3 as a 3 will remain. So 3 will be the remainder. If counted in fives, 4 will remain. That means A is equal to 5 of quotient plus 4 as a remainder. So next, if counted in 6, 5 will remain. What it will become? So if counted in 6, 5 will remain. That means A is equal to 6 of quotient plus 5 as a remainder. If counted in 7, it remains 0. If counted in 7, it remains 0. That means A is equal to 7 of quotient. The remainder will be 0. So let us try to solve this problem. As they said earlier, A is less than or equal to 150. So now what we are going to do, we will come from down. If counted in sevens, nothing will remain. So 150 is lesser than or equal to 7 of quotient. As we know that A is equal to BQ plus R. So A we took as 150. 150 are lesser than or equal to 7P. Next, if counted in 6, 5 will remain. So 150 lesser than or equal to 6 of quotient plus remainder is 5.
So next one, it is if counted in fives, 4 will remain. So 150 is lesser than or equal to 5 of quotient plus remainder is 4. So now next is if counted in fours, if counted in fours, how much is remains? If counted in fours, 3 will remains. So 4s plus 3. This is a quotient. So if counted in threes, 2 will remain. If counted in threes, 2 will remain. So 3 of quotient plus 2 as remainder. If counted in pairs, 1 will remain. So 150 lesser than or equal to 2 of quotient plus remainder as 1. So as we know that as a is lesser than or equal to 150, we will take 150 lesser than or equal to 7p as a key point because here there is no remainder is 0. With the help of this, we will try to solve this problem. We will take these two, first we will take these two and try to solve the problem. 21 into 7 is 147. We will try to incorporate this 147. We will take this as a dividend and 6 as a divisor here, which is 24 plus 3. But we need here 5. See, as a is lesser than or equal to 150, we will take 150 lesser than or equal to 7p as a key point because there is no remainder is 0. We will take this as a key point and try to solve this problem. So first 21 as it is in a lesser than or equal to 150, lesser than 150 is 147, that is 21 into 7 is an 147. We will take this 147 as a dividend and the divisor is we will incorporate in this equation. 147 is a dividend and 6 as a divisor. We got 24 as a quotient plus 3 as remainder, but we need 5 as a reminder. So it is not right. So next we will move to 20 into 7. 20 into 7, 140. So just we will check 140 divided by 6, which it is 23 plus of 2, 2 as a reminder. In this case, no, 140 is not the right answer because the remainder here is 2. We need the remainder 5. So again, we will go with 19 into 7. 19 into 7, 133. So here 133 divided by 6 is equal to 22 plus 1. 1 as a reminder. So this answer is also not right because we need a reminder 5. But here the remainder is an 1, so it's not a right answer. So again we move with 18 into 7. 18 sevens are 126. So 126 divided by 6 is equal to 21 plus 0. So this also not satisfied. This also not satisfied for our equation. So we will move to 17 into 7. 17 sevens are 119. So here 119 divided by 6. 119 divided by 6, which is 19 of 196 or 114 plus 5. Here we got the remainder as 5. So we can check now that 150 is lesser than or equal to 6q plus 5. Here this 119 satisfy our requirement. If we divide 119 by 6, we will get the remainder as 5. So let us check whether this 119 will satisfy with other these criterias. So let us take with let us take let us check with 119 is equal to, as we said here, 6 of 19 plus 5. If we divide 119 by 5, we will get 23 plus remainder 4. I hope now we got satisfied this criteria. So now we are moving to next 119 divided by 4, which will be 29 plus remainder is in a 3. I hope now it is satisfied this. Now 119 is equal to 119 divided by 3, which is 39 as a quotient plus 2 as a remainder. So this also satisfied our criteria. 3, if we count 3, if it is counted in 3, the remainder will be 2. If it is counted in pairs, the remainder we need as a 1, as this also satisfied our criteria. So now we found out that the seller man had 119 eggs in his basket by using Euclid's division algorithm.
I hope everyone understand what is Euclid's division algorithm. So, in next topic, we are going to see Euclid division lemma. Thank you for watching this video. If you like my video, please share and subscribe calculation for more videos. Thank you.